What we're going to look at first is we're going to look at sort of his idea of 4 different designs, and there's some things in here that we're going to have to talk about how to change. I don't know if you can see my mouse. You can't. It doesn't look like. Oh wait, maybe you can if I go here. No, it doesn't look like you can. But at any rate, in the foreground here, in our to the left of his little box and the right of his box, he's got the red square on the right there. That's a bypass with a valve that would open into a bench, and then the return is the not red opening into the bench. And these are a couple, I'm just going to flip through these really quick. What we've got is we've got a few different options. So we've got just sort of an opening into a bench with the return, the entrance and exit at roughly the same height. You can see the exit's got a little lower threshold right here. You can't, oh yeah, maybe you can see my mouse. A little lower threshold there. And a little higher threshold there. So that's his number 1 design choice. Number 2 is kind of the same thing, but with a tube extending down the bench. Number 3 is the same thing, but with a lowered pickup for the intake, for the exit into the chimney. And number 4 would just be putting the chimney on the floor. And so of all these, you know, what the question is kind of what's the best, what are the pros and cons? And this is a really kind of a open-ended question. I think if it were me, Peter, I would go for this simplest design. You can extend this down the bench like this in your other design, and what that'll do is that'll bring the heat down to the far end of the bench and then have it spread out as it comes back. It really kind of depends on the size of your bench and everything else. I don't know that in your design this is necessary. It might be useful. It wouldn't hurt. If it's easy to do, you might try it. But this design, I think, is the simplest. If you move the chimney exit down to the floor like you have here, or even here, I fear that you are going to cool the gases too much, because now you've added the floor to that whole equation of surface area. And I fear you're just going to create too much load on the stove. So I wouldn't do either one of those. This one or this one are roughly identical, and I think either one of these are going to be ideal. Now, you want to make sure, and this is one of the questions that Peter asked later on, you want to make sure that all of these openings are a 6-inch chimney's cross-sectional area at minimum. So that's 29 square inches. So this one back here looks to be too small, but I can't tell for sure. But that is an absolute necessity, and ideally they're going to be a little bit bigger. So I know that you asked that question in just a minute. So we'll get through these slides and we'll get to the questions. So this was the question, is he wants the oven as hot as possible, so the entrance to the bench is closed. In other words, can he have it just go through the oven and not through the bench? And yeah, that's absolutely possible, and that's the best way to keep the oven as hot as possible. This is really astute, is the elevation of the oven, the elevation of the bench, these things all are interrelated, and if they're at the same elevation and it's all open passageways between, then the oven will never get any hotter than the bench, and you really won't have an oven at all. So if you want the oven to be able to be hotter than the bench, it needs to be either above the bench entrance and exits, or be able to close off the bench. So this is, I think, a really good plan, to have separate bypasses, to be able to leave the oven exposed but close off the bench. Now in this question, this is kind of interesting. He's got the firebox here on the right with the cooktop on top, and then he wants to step down to the oven. And the question is, what are the consequences if I lower the oven ceiling? Besides loss of space and less different temps inside the oven, I assume the oven will be hotter overall. This is a great question, and this is a great design idea that Peter brings to this design. He lowered my original flat top here so that he could bring the ceiling down lower over the oven, and in that way you will get a hotter oven, because you'll have less of a bell around it and you'll have smaller airspace around it to heat. Now you need to make sure, Peter, that you retain sufficient flow all the way around the oven. And again, we're looking for that 29 square inches or 6-inch chimney cross-sectional area in all dimensions. You really don't want to pinch off the top just because you know it can go around the back, because what will happen is it'll prioritize going around the back and it won't send any heat over the top. So these are things you'll want to play with a little bit, but in general, yeah, you can lower that oven ceiling and you can, in effect, bring the oven higher in the oven chamber and make a smaller oven chamber, and all those things should lead to higher potential cook temperatures. So the next question is about the bypass. And here Peter's asking if he can do a bypass like this. This is a nice simple way to do it with a swinging gate type bypass. And Peter, here's what I'll tell you, is that this will work fine, with the exception of it must open all the way here so you don't make this pinch right here. You see, you've reduced the flow of gases here by so much that this is going to be a choke point. So if this gate bypass can open all the way so it's flush over here, and this distance here remains fully open, then you can do this. But if not, if you can only open at 45 and it's going to pinch off this corner here, then I recommend doing a sliding bypass gate instead, so that you can slide it out of the way. Now the actual opening for the bypass here, he says, is the opening 6.1 inches by 2.1 inches big enough. And in this one spot in the stove, it is okay to break that rule I just told you. It is all right to be smaller than cross-sectional area here in this part of the stove, because we only need some of the gases to go that way, because we're just trying to provide some chimney priming heat right out of the core up into the chimney. So we don't need the full 6-inch chimney, because don't forget, there's still room for the gases to go all the way around the flow of the stove and have that full flow. So we're not restricting the flow of the stove. If we were to close off all the other passageways, then yes, this bypass would need to be 29 square inches. But since it never runs with the rest of the stove closed, in other words, there's always another access for the gases to access the chimney, then this can be reduced size opening. It's the only place in the stove where that's allowed, and it's the only reason it's allowed there is because it's never run as the single chimney exit. So hope that makes sense. Are you guys following me? I don't know if you are. I'm kind of going through some specific stuff, but hopefully the rest of the gang is getting some stuff out of this as well. So the general questions regarding his designs: how do I build entrance and exit from the bench higher than the bench floor? How do I build entrance and exit from the bench? Stove floor is higher than bench floor. Oh yeah, we already talked about that. So that'd be design 2, I think, is the best design. And 7 is an easier design possible? I don't think so. I think your design 2 is really good and really simple. And then the last question, sorry to ask again, is it really necessary, or can it be less than 6 inches as long as the chimney is 6 inches or more? No, it is absolutely mandatory that all tubes in the system are 6 inches or more. And 6 inches is the absolute minimum, and even that is pushing it. So to just go back over it, I think this really simple design with a bench entrance and exit kind of up here off the floor, with just slightly changed in elevation due to your exit height and your entrance height, I think this is your best bet, Peter. I think that's the simplest way to move forward with this design, and will give you the best performance. Down the road, should you want to make some adjustments, then you can play with your adding tubes to either one of these to extend and lower the entrance or the exit as you see fit. But I don't think you'll want to do that. I don't think they'll be necessary, but you can always do those after the fact. I think your goal at first is to get the stove so that it starts up easy, runs smoothly in all conditions. Then you can start pushing that, bringing that exit temperature down and pushing your max efficiency. But you'll find that the stove performance really suffers as you try and push those limits, and everyone's going to have sort of their boundary of what they're happy with in terms of like how difficult it is to start, how often it smokes back, how hard it draws, and how fast it lights up, and how fast it heats the cooktop. Remember that a stove that draws well, lights well, and heats quickly. So if you like want to light your stove and go right to boiling water, you want a stove that doesn't have a lot of restriction or really difficulties drawing hard right off out of the gate. So that's my general feeling about all those questions. So I hope